So let's have a look at 3C, reflections. So we went D, R, T, dilations, reflections, translations. We've done dilations and we've done translations. Let's do reflections. Why do we leave it till last? Because it's the easiest. So let's have a look. A reflection in the x-axis. So it's like you fold along this line here. So what happens is this will go to here, this will stay, and it basically, this will go to there, and it flips around the other way. Hang on, that's not very good. So I can see if I folded on that x-axis, I would get not quite the same. It should look the same. Similarly, if we folded in the y-axis in here, if we folded that across, this would go to here, this would go to here, and that would go to there. So it's going to end up looking like this, a reflection in the y-axis. And that's something you might be familiar with from parabolas and your truncuses anyway. So I'm hoping this isn't brand new for you. And I'm hoping that picture looks all right. It's not great, but you know what I'm doing. So from the graph of f of x, we have the following two pairs of equivalent processes. If you reflect in the x-axis, your x-coordinate stays the same, but your y-coordinate becomes negative. X-coordinate stays the same, y-coordinate becomes negative. So in this case, x dashed, y dashed, we get x dashed equals x, y dashed equals minus y, or minus y dashed equals y. And we can sub that in. So we replace y with y dashed. So what we end up is y equals negative f of x. So we start to look and say, hang on, if it's in the x-axis, we just pop the negative out the front, and that seems consistent with this one. Anything from the x-axis, we pop it out the front. Anything from the x-axis, we pop it out the front. It's still the same with the negative, so it all starts to gel a bit more. So you might think anything from the y-axis, I am anticipating that it will go on the inside, but let's see why. X, y, in this case, the x, when we reflect in y, the x-coordinate changes, it flips over and the y stays the same. So this becomes minus xy. So we get x dash, y dash. X dashed is minus x, y dashed is y. So we replace x with minus x dashed, and it becomes y equals f of negative x. So anything from y is inside, anything from x is outside. So let's have a look at, I think I've just got one example. Yep, and a multiple choice question. And then you can go ahead and do 3C, which is reasonably quick. So example 4a, find the equation of the image when it's reflected in the x-axis, it goes outside. When it's reflected in the y-axis, it goes inside. And a multiple choice practice question. The graph of y equals 3 on x plus 4 is reflected in the x-axis and then in the y-axis. So what's the equation of the final image? I am going to let you stop the video, have a go at that question and see whether you get it right. Right, now the order is important. Reflected in the x-axis, that's the first thing. So 3 on x plus 4, anything from the x-axis, we pop the negative out the front. So now it becomes minus 3 on x minus 4. Anything from the y-axis, we replace x with minus x. So then it becomes minus 3 on minus x minus 4. So we get 3 on x minus 4 because those negatives cancel out. So the answer is in fact D. All right, when we get to the next one, exercise 3D, that will bring everything together. So please finish those 3C questions. And once you've done A, B, and C, we can launch into 3D next lesson.